So we need to consider the quadratic pattern 3, 5, 8, 12, which goes all the way to infinity. And the word consider means you look at what you are given and you make sense out of it. So now that it makes sense to you, then please determine the value of a term that is at position 26. So in order for you to find the value of a term that is at position 26, that's if and only if you know the general term of your pattern. So that's the first thing we need to determine, all right? So this is our pattern. We have 3, 5, 8, 12, and it goes on all the way to infinity. So we begin by finding the first differences. And one thing we know about the first differences is that they actually give us a linear number pattern. So when you say 5 minus 3, you get a 2. 8 minus 5, you get 3. And 12 minus 8, well, you simply get a 4. And this is your first differences. But we are not done because we understand that a quadratic number pattern is characterized by a second constant difference. So when you say 3 minus 2, you get a 1. 4 minus 3, you also get a 1. And this is your second difference, which is constant, of course. So now, we know that this is the general term, or rather the standard form for a quadratic number pattern. It's an squared plus bn plus c. So in order for us to find the value of a, that's if we take 2a and we equate it to the second difference. So which means the value of a is just going to be 1/2, all right? Okay, fine. But in order to get the value of b, that's if we say 3a plus b, and we equate this to the first term of the second differences, which is going to be 2. You don't equate 3a plus b to this one or to that one. It's strictly to the first term, okay? And since we know that the value of a is 1/2, then it means in order for us to find the value of b, that's if we say 2 minus 3/2, all right? And of course, 3/2 is just going to be 1.5. So it means the value of b is also going to be 1/2. Well, that's fine. Now, what about for the value of c? Well, here we take a, we add it to b, we add it to c, and we equate everything to the first term of the quadratic pattern itself. So we have 1/2 plus 1/2, but this one is unknown, and everything is equal to that. So this means our constant is just going to be 2, because this gives you 1, and if you take 1 to the right, it becomes negative. So this means our general term is just going to be 1/2 n squared plus 1/2 n, and then you say plus 2. And before you can do what, you need to test if indeed this general term works. So you can simply go to your calculator and try to substitute term number 4, for instance, to see that it gives you a 12, okay? So let's go ahead and do that. and see how much we get. Well, indeed, we get a 4, in fact, a 12, sorry. So it means it works. So now that we have proven beyond reasonable doubt that indeed it works, then we can go ahead and find term number 26. So this is how we find term number 26. And then we say plus 2 there. And let's see how much is the value of a term that is at position 26. Well, we are simply going to get 353. And this should be it. You've got your nice and beautiful 6 marks. Imagine. So let's move on to the next problem. And the last questions are always nice. And this one is nice as well. So let's analyze. They gave us the conditions or the characteristics as they call them. So here they say a certain quadratic pattern has the following characteristics. The first term is P. The second term is 18. We don't know what is term number 3, but term number 4 is 4 times term number 1. In other words, term number 4 is 4p. But this is what they say to us. If you take term number 3, then you say minus term number 2, which is 18, you get a 10. So it means we actually know what is term number 3. But the question here says to us, please determine the value of P. And this is for 6 marks. Imagine. Now the question is, how are we going to get the value of P? What is the principle that we must use? Well, we are simply going to use the fact that a quadratic number pattern is characterized by a second constant difference. That is our guiding principle. So they said to us term number 1 is P, and term number 2 is 18. But they said if you take term number 3 minus term number 2, the answer is 10. So this means term number 3 has to be 28, right? No, it's actually 38, sorry. Because if you say, wait, what is it? Guys, maths is killing me. It's supposed to be 28. Sorry about that. Hey, mental maths. Yeah, I think I need to go to my calculator. Hey, yeah, no. It's in the evening, guys. I've been thinking all day long. Please forgive me. I know it's an excuse, but please cut me some slack. But it should be, right? Yeah. So yeah, term number 3 is supposed to be 28. Hey, never rely on your mental maths. The calculator is always there, guys. That's the bright side. And then what is term number 4? Well, term number 4, they said it's 4 times term number 1. So this is what we are having, right? And then we need to find the first differences. So we say this one. Then we come back again and say for this. And come back for the last time. And say for that, all right? So the first term and the first difference is 18 minus p. Well, it's 18 minus p. And 28 minus 18 is 10. And 4p minus 28 is 4p minus 28. We are done with the first differences. Okay. So let's move along to the second difference. So now we need to come and say, well, 10 minus 18 minus p, and then come back again and say 4p minus 28 minus 10. So these ones, I'm just going to do them aside and write the final answer there. Remember, every time you're subtracting two terms, you need to open a bracket so as to distribute the negative sign. So here we actually have 10 minus 18 plus p. And this gives us negative 8. So we actually have p minus 8 here. All right. Then we move along and we say, well, here we have 4p minus 28 minus 10. So we simply get 4p minus 38. And what we have here is our second difference. And what is it we know about the second difference? Well, it's constant. What is the meaning of constant? It means p minus 8 is actually equal to 4p minus 38. But if you have a difficulty understanding this, you just need to refer to the previous problem that we did. So here we actually said 1 is equal to 1. So yeah, that's the meaning of the difference is constant. So since they're equal to each other, we might as well equate them because we want to find the value of p, right? So now it's time to solve for p. So we take this p to the right-hand side. It becomes positive, in fact, negative, sorry. So 4 minus 1 is 3. And then we take negative 38. To the left-hand side, it becomes positive. So negative 8 plus 38 gives us a solid 30. And dividing both sides by 3, then we find that the value of p is just going to be a very nice and beautiful 10. Over and out.